Hi there. In today's video lesson, we will be talking about the discovery of the atom and the subatomic particles, part 1. The discovery of the atom and the subatomic particles, part 1. And if you haven't subscribed to the channel, please do well to subscribe, like, and don't forget to give a positive comment. Alright, let's proceed to the main lesson. Dalton's atomic theory. John Dalton's atomic theory. In our recent video, we learned about the fact that matter is made up of tiny or discrete particles, and the idea behind that is termed as the particulate nature of matter. We also made mention of the fact that there was an ancient Greek thinker by the name Democritus who suggested in 500 BC that matter is made up of tiny particles, and these tiny particles that matter consists of was named by this great thinker as atom, from the Greek word atomos, which means indivisible. We proceeded to the fact that John Dalton, being an English schoolmaster, conducted many experiments about the atom. He also believed in the idea that indeed matter is made up of tiny particles, and he proceeded that this atom that matter is made up of combined to form compound atom called molecule. So Dalton, who was born in 6 September 1766 and died in 27 July 1844, was also a physicist and a meteorologist, and he was the first person to explain that everything that exists is made from atom. I want you to take note of that. So we have a picture of Dalton here. So this is a picture of John Dalton. Alright, so let's proceed to the next slide. Okay, the Dalton's atomic theory. So we made mention earlier that Dalton performed a lot of experiments on atom, and at the end, or as a result of the numerous experiments that he conducted about the atom, he formulated that matter is made up of smaller particles called atoms. Made up of smaller particles called atoms. And the second thing that he said is that these atoms cannot be subdivided, created, nor destroyed. In other words, what he was trying to say is that you cannot divide an atom. You cannot create an atom. It exists in nature. And lastly, you can't destroy an atom. Thirdly, he said all atoms of a given element are identical, meaning they have the same size, they have the same mass, and they have the same chemical properties. Fourthly, he said atoms of different elements have different masses, different sizes, and different chemical properties. And lastly, he said atoms of different elements combine to form molecules or compounds in a simple whole number ratio. So these 5 main points sum up what is termed as John Dalton's atomic theory, or in simple put, Dalton's atomic theory. Now, after Dalton came out with his theory in the year 1808, many scientists also conducted experiments about the atom, and their discoveries limited some of the points that Dalton said earlier. For instance, Dalton said that the atom cannot be subdivided, created, nor destroyed. But this point is limited because of the discovery of the subatomic particles. We learned earlier that we have a lot of subatomic particles. We have hypron, we have neutrino, antineutrino, we have the positron. All these are examples of subatomic particles. We have electron, we have neutrons, and we have protons. But for the purpose of this lesson, we will limit ourselves to electrons, neutrons, and protons. So the discovery of these subatomic particles, which are within the atom, disprove the idea that the atom cannot be divided, because they are within the atom. So that disproved that part. He also said that it cannot be created nor destroyed. Now, there was one scientist by the name Henry Becquerel. He discovered, or he is the brain behind what is termed as radioactivity. And radioactivity talks about the fact that an unstable nuclide can be disintegrated, can be splitted, or can be destroyed. So with the existence of radioactivity, scientists are able to destroy an existing atom. And anytime that an existing atom is destroyed, new ones are formed or are created. So because of the existence of radioactivity, that idea that atom cannot be created nor destroyed has been disproved. And as a result, that point of Dalton is limited. Dalton also said that atoms of a given element, or atoms of the same element, are identical, having the same size, mass, and chemical property. That one too is limited or has been disproved due to the existence of what is termed as isotopy, from which we got the term isotope. Now, we talk about isotopy. Isotopy is the occurrence or the existence whereby atoms of the same element having the same atomic number but different mass numbers as a result of difference in neutron numbers. So we realize that atoms of the same element can have different masses as a result of different in their neutron numbers, and that also limited or disproved the idea that atoms of the same elements have the same masses. For instance, we have chlorine isotopes. We have chlorine 35 and chlorine 37. In other words, they all have the same atomic number of 17, but their neutron numbers are not the same, and as a result, different mass numbers. So we have chlorine isotope having a mass of 35 AMU, which means atomic mass unit, and then 37 atomic mass unit. We have carbon 14, carbon 12, carbon 15. All these are masses of carbon, and as a result, they are isotopes of carbon, even though carbon is having atomic number 6, but different masses being 12, 13, 14. So I want you to take note of that. So the occurrence whereby atoms of the same element having the same atomic number but different masses as a result of difference in their neutron numbers is what is termed as isotope or isotopy, and that limited the point or the idea that atoms of a given element are identical by mass and size and have same chemical property. Thirdly, Dalton said that atoms of different elements have different masses, different size, and chemical properties. That one too is limited due to the existence of what is termed as isobar. Isobar too is the occurrence whereby atoms of different elements having different atomic numbers but same atomic masses. And we can see that from argon and calcium. Argon is the 18th element on the periodic table, calcium being the 20th element on the periodic table. But they all have atomic masses being 40 each. And that disproves the idea that atoms of different elements have different masses. Because in the case of argon and calcium, though they are atoms of different elements, but they have the same atomic masses. And that concept is termed as isobar. Fourthly, he said, atoms combine to form molecule or compound in a simple whole number ratio. But we don't see that in complex organic compounds like sugar. For instance, we have sugar with 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. So the ratio of carbon to hydrogen to oxygen is 12 is to 22 is to 11, which is not simple. In other words, there is no integer that you can divide through by 12, 22, 11, and you get whole number throughout. So that also disproves that point. So these are the limitations of John Dalton's atomic theory. Dalton's model of the atom. John Dalton perceived the atom as a small hard ball which is indivisible and cannot be created. So this is a typical example of how Dalton perceived the atom to be, as a small hard ball by this blue round object here. That is Dalton's model of the atom. The atom is a small hard ball which is indivisible and cannot be created. That is how Dalton perceived the atom, and it is termed as Dalton's model of the atom. As a result of studies and many experiments, we just learned that Dalton's theory was disproved or is limited. So there has been a modification on his theory, and that modification is what is termed as modern atomic theory. And the first point says that an atom is no longer indivisible as it has a complex structure of subatomic particles. Example, electrons, protons, and neutrons. Second, atoms of the same element may possess different relative masses as a result of isotope. And we learned from the previous slide that indeed atoms of same element may possess different relative masses or different masses. And we learned that using chlorine isotopes as an example. Thirdly, certain atoms of different elements have the same relative masses, but their chemical properties are entirely different. We saw that from our previous slide, from the term isobar, using argon and calcium as an example. Fourth point, although the atom is composed of subatomic particles, it is still the smallest unit that take part in a chemical reaction. So I want you to take note that this theory was used to explain the law of chemical combination of matter, that is John Dalton's atomic theory. And Dalton also did a study on the relative masses of atoms and gave symbols to some elements and compounds. So this will be the end of our lesson. So maybe you are thinking that, does it mean that it seems like Dalton's atomic theory has been disproved, almost all, and so it is not important? No, that is not the point. His theory was used to explain the law of chemical combination of matter. Don't forget, in our previous video lesson, we learned that Dalton said atoms combine to form compound atoms called molecules. Alright, so this will be the end of the lesson. In our next video lesson, we will be talking about the part 2 of the discovery of the atom and the subatomic particle. And the main thing that we are going to talk about there is Joseph John Thomson cathode ray tube experiment, which led to the discovery of one of the subatomic particles called electrons. Alright, so don't forget to subscribe to the channel for more video lessons. Don't forget to leave a comment. Don't forget to like as well. Below are links to my WhatsApp group where you can ask any question bothering you in chemistry, and you can also ask for video lesson on a specific topic which we have not yet uploaded on this very channel. God bless you. Don't forget to share to bless others.